Hi everyone. I'm going to go over our Lab 1 experiment, and I'd first like to say watch the videos on how to use the equipment before you watch this video. So we have one on how to use the breadboard, how to use the multimeter, and how to use the oscilloscope. So watch those first so you understand what's going to be going on, and then you can watch this one and read the lab handout. Okay, so the basic idea for this lab is to become familiar with the equipment in the lab. So there's the breadboard that we're going to be using, there's going to be the oscilloscope and the digital multimeter. So you should know how to use the equipment and explore and play with it a little bit to explore the functions. If you finish the lab early, please stay until the end of the period and explore more of the functions and get really solid with how to use the equipment, because it's going to become very valuable later. Okay, so this is just basically a practice lab. Okay, so let's get into it a little bit. And so let me talk a little bit about the voltage supplies on the breadboard. Now, we talked about that a little bit in the breadboarding video, and I'll just expand a little bit. So now there's one thing that I didn't mention actually in the video, and that is this connection here, and that's a green one, and it has the symbols like this on it, and it also has this symbol. Okay, so that's representing earth ground. A detailed explanation of this is really beyond the scope of this video, and but it's a very interesting topic. Grounding is very interesting, and it could be a whole course on its own. But what I'm going to recommend to you is to not use that and not to consider that as ground, okay? And if you want a detailed explanation, I'm very happy to speak with you about it, or you can ask your instructors. Just so that you know, that connection here, that green one, it also connects to the body or the chassis of the breadboard system. So what's painted in red, okay? And that is for safety. So if a wire, let's say 120 volts wire, gets loose and touches the chassis inside, then the whole thing doesn't become live and risk electrocuting you. So it'll actually trip a circuit breaker if that chassis is grounded. Okay, so it's a safety feature, but it doesn't help us when we're doing our lab experiments. So don't make any connections to it, or else you might get confusing results depending on what you're doing. Okay, so now let me talk a little bit about these voltage supplies. So now each of those supplies is an independent source, and if you were to want to have let's see, maybe I just can stay here. If you wanted to have available to your system plus 15 volts, let's see, I'll use a different color, plus 15 volts, 0 volts, minus 15 volts, and let's say plus 5 volts. Now, what you would do in that case, because these voltage sources are independent, you would have to make a connection between the two voltage sources. So since we've defined this one as our zero reference or ground, then what we would do is we would make a connection from here, I don't know if you can see it yet, from here to this one, to the negative of the 5 volt source. So then that will make this plus 5 volts as related to these bottom 15 volt sources. Okay, if we didn't have that connection, this 5 volts wouldn't be 5 volts, it would be floating. It would be any arbitrary voltage, okay? Because it's an independent source that's not connected. So you have to make that connection from the common to the minus 5 volts. Okay, or to the minus of the 5 volts. Now let's say instead of 5 volts, you wanted to make that supply provide minus 5 volts relative to the plus or minus 15 volts. Then you would take that common wire, okay, and then you would connect it to the plus side, okay? So then that would make the bottom one, which is a negative, that would make it 5 volts, okay? So these are relative voltages. So that's something to keep in mind. Okay, so now if you understood that, let us do something more tricky, okay? Let's say in your system you wanted to say you had, oops, maybe make this 0 volts and make this 15 volts, plus 15 volts, and then make this plus 30 volts, and then make this plus 5 volts, okay? How would you wire it up? You can have all of this. You can make a legal circuit out of this, okay? So then what you would do for this 0 volts, you take this very bottom connector, which is minus 15 volts, as that's what it's denoted, but you can say that's 0 volts in our system, and then you can connect it all the way up to this guy here, so that's the negative of the 5 volts, and then you'll have those voltages available to you. So these are all relative, okay? So just trying to give you an insight into how those voltage supplies work, okay? And if you have any questions about that, you can ask your instructor. Okay, so then, now the lab handout starts talking about the oscilloscope and the function generator and how to make some connections. So talking a little bit about here and how you can have an improper connection with your oscilloscope. So now, this is representing the oscilloscope, okay? So this is an oscilloscope connection here, okay? What does that mean? Well, the connection is actually with the oscilloscope probe, and let's take a quick look at what the oscilloscope probe looks like, okay? So you've seen this in the video with the oscilloscope, but this is the oscilloscope probe, okay? And it's very similar to the leads of the voltmeter. So this here is the part that connects to the oscilloscope, and then the cable runs to the other end, and then so you have the probe tip, and that is, if it was on a voltmeter, it would be your red lead, okay? And then, here, let's see, I'll use black. This is the ground clip, it's an alligator clip, and it corresponds to the black lead on your voltmeter, okay? Okay, so that's what that is. So now let's go back to that drawing. Okay, so now in this context, so this would be the probe tip, so probe tip, so it would be like the red lead on the voltmeter. That's this guy right here, okay? And then this is the ground clip, and that's the black lead, okay? So that's what that drawing is representing, okay? So this is the ground clip here, okay? So now, let's see. Now, one thing that's interesting about the oscilloscope probe, so we had, okay, let's go back down to it. So the ground clip is actually connected to the neutral. In fact, it's connected to the earth ground, okay, in a system. So if you're to use two probes, they're going to have two ground clips. Those two ground clips are essentially at the same node or same voltage. So if you're going to connect them to a circuit, they have to be at the same voltage. If they're at different nodes with circuit elements in between, you're going to short out that circuit element. So you have to be very careful on how you connect the ground clips. So basically, connect them to the same point on the circuit and you should be okay. And of course, for anything I say, you can just ask your TA or your instructor for more clarification. Okay. And so now it's in the second drawing here. So let's say in this drawing here, it is showing you a ground connection here. And how you would actually get that is if you were to connect the circuit in the breadboard to the ground. So let's say this VS, let's say that VS was 15 volts, okay? So then how can you have that grounded? So then what you would be doing is you'd be making a connection from this common to the ground, and then you'd be grounding it, and then you would be risking that if you put your ground clip on the wrong place, you could cause a problem, okay? And that's what's denoted in the drawings just below. So you see here, we've got the ground clip connected to this part of the circuit, whereas the circuit ground is down here. So what that results in is a short circuit. So let's just say there would essentially be effectively a wire connecting those 2 points together, and it would mess up your circuit measurements, okay? But you can get around that by not connecting to this guy here, okay? So we don't want to connect here, okay? So no. Okay. Okay, I think that's it for that part. You'll have to read it in more detail. This lab handout has very detailed instructions. I'm just giving an overview. So now, over here on the left, we're using the digital multimeter, and it's showing on the left-hand side how to make a voltage measurement. And it's making the point that you don't have to worry about where you put the negative lead in the circuit to worry about shorting out or doing something improper, like how you might with an oscilloscope probe. So you can put the negative lead connecting here, and that's no problem, and then the positive lead here. Okay? And the polarity matters in order to make the correct voltage measurement so you get the right value. And now I just want to make a point that if you have a voltage across this resistor R1, let's just say I'm going to use this blue. So let's say you define the voltage VR1 like so, plus or minus. Well, that designation of that voltage, VR1, if you want to measure it with the right polarity, you would put the negative lead to where the negative is in the representation for VR1, and then the positive lead, the red one, to the positive side. So that's what that means when you apply a voltmeter to a component and where there's a polarity. If for some reason I wanted to define the voltage in this direction, this would invert the polarity of the voltage measurement, and so I'd have to multiply it by -1, or I have to switch the leads around. Okay, so direction matters. Okay, so now on the right hand side, it's showing how to connect an ammeter. Oh, before I leave the voltmeter, let's consider something here. So now I'm looking at the voltmeter. So that's the voltmeter there. So now, what property does it have to have when it's making a measurement in this configuration? So it's making a parallel measurement across the resistor. So what would the voltmeter's resistance have to be for it to be a good instrument. Okay? So for it to be a good instrument to make a measurement, we don't want that instrument to interfere with the phenomenon that it's measuring. Okay? So if we apply the voltmeter on there like that in parallel, we don't want to affect how the circuit is operating. So if that voltmeter appeared as an infinite resistance, so then no current would flow through it, so then the circuit would have no interaction with that voltmeter. So then no current would flow through the voltmeter, and the voltage, let's say VR1, would stay the same whether the voltmeter is connected or not. Okay? So a property of the voltmeter is it has infinite ohms resistance. Okay? So now let's look at the ammeter. Now the ammeter is used, oops, sorry, I messed that up a little bit for you. Okay. So the ammeter is placed in series with a circuit. So if we have some voltage source here, and let's just call it 10 volts, and then we have an ammeter here, so I'm just calling it like this, AM, and then it's going through some resistors, and let's just say that's 5 ohms and 5 ohms, and I know there's going to be some current flowing, right? So the current is going to flow this way, call it I. Okay, and let's do a little bit of Ohm's law here. Okay, so I is equal to V over R, and then so that's 10 volts divided by 5 ohms plus 5 ohms, right? They're in series, so that works out to 1 amp. Okay, so that's what I should be measuring, positive 1 amp, and I've drawn the current going in that particular direction. So now how do we have to set up that ammeter to get a positive reading? Well, we have to connect the red lead over here, so that's the positive, and the black lead over here, and that's the negative. And with current flowing in this direction through it, we'll get a positive reading in the ammeter. Okay? So the direction matters. If we were to flip the positive and negative around the opposite way, we would read the negative value of the current. Okay. Now consider, what property does the ammeter need to have in order for it to not interfere with the circuit? Okay. What kind of resistance does it have to appear as? Well, it's in series with the circuit, and that's how we measure current. So we have to break the connection and go in series with it, with the current. Okay, and so for the ammeter to not interfere with that measurement, it has to appear as a zero resistance load. Okay, so then let's just make a note of that. So ammeter appears as 0 ohm resistor. This is also known as a short circuit. Okay. Okay, so it's good for you to know that, and it has a huge impact on how you use the ammeter, because you could really screw up if you use it incorrectly, and you can short a voltage source and blow up the ammeter. Okay. So, oh yeah, going back to the voltmeter, infinite ohm resistance, but you know, we also can call it open circuit. Right? It looks like an open circuit. Okay. Okay, this part of the lab talks about the breadboard, but you've watched the video, so you should have a good idea about how the breadboard works. And this is the circuit that we're going to build in the lab on the right. So we have 4 series 1000 ohm resistors, or 1K, stimulated by a 15 volt source. Okay. And you know what? Just ignore this ground. Okay, don't connect it to ground. Okay, don't connect it to that green terminal that I said don't connect it to. Okay, don't connect it. Okay, so just ignore that. Now you'll notice here there's an X here. That just is labeling that part of the circuit. So that's node X, this is node Y, and this is node Z. Okay, so those are just designations to help you with the latter parts of the lab to follow the instructions. And the lab goes on and tells you to make some voltage measurements. So right over here, where it's telling you how to measure the voltage. Okay, and it's saying to connect to nodes X and Y. And then later it tells you to switch around the voltmeter and connect to X and Y again. So now let's see where, oh sorry, not X and Y, X and Z. Okay, sorry. So let's go back up to the circuit. So where's X and Z? So X is here and Z is here. Okay, so what that means is you're going to put your voltmeter, so this is VM for voltmeter. Okay, so first let's say you're going to put your red lead here and your black lead here and measure the voltage. So now just looking at the circuit, you should be able to tell me what that voltage is going to be. Okay, and then it tells you to switch the leads around. So let's take those out, and we're going to do the opposite. So this time I'm going to put the black lead over here before it was the red one, and I'm going to put the red one down here and before it was the black one. And then you're going to make another measurement and see how they compare. And you should be able to predict that right now from what you know from circuits. Okay. So then let's see what the next part is going to be. Okay. So that was a voltage measurement. Next one is doing resistance. Okay, so that's good. So now over here we're doing resistance. Okay. So then we have to switch the voltmeter into the resistance mode, and then we connect the DMM to nodes X and Z. Oops, why did it do that? To nodes X and Z, and measure the resistance. So let's see where that is. X and Z. Oh, it's the same place as we were before. Okay, so there's X and there's Z. So we're going to take the ohm meter. So let's say ohm meter. So that's my instrument, and it's saying make a connection. So you can have, let's say, the red lead here and the black lead here, and make the measurement. Okay, now you got to pay attention to what it's saying. It says, this is super important, remember that resistance measurements should only be made only on non-energized circuits. So we're supposed to temporarily disconnect both connection wires to the voltage source. So what we got to do before we make our measurement is take these wires out. So here, I'm going to show that we're taking the wires out here. Okay, so we take that wire off and that wire off. Okay, and then we're just measuring the resistance directly of those 4 1000 ohm resistors, so you can predict what it's supposed to be. Okay, now it's not just like we don't just turn off the voltage source as you saw in the video of how to use the ohm meter, we have to actually disconnect the wires, because even if the voltage source is off, it still is part of the circuit and it will interfere. And then then it asks us to reverse the connections and make the measurements again at X and Z. So let's see what that would look like. So that just means taking the red and the black and flipping them around, okay? So red could go there and black could go there, so that's the opposite. And then is the resistance going to be different? So you can make that observation and understand a little bit about how that's working. Okay, and then it asks us to place a short circuit in parallel with the lowermost resistor, okay, between nodes Y and Z. Okay, so what does that mean? So that means when we're making our resistance measurement, we're going to add a wire, and that wire is going to go, let's see, I'm going to use a blue line, and that wire is going to go across here like this. Okay, so now what's going to happen, of course, is all the current would flow through this resistor, through this, so here, maybe in green. So it would flow through here, flow through here, flow through here. And now when it gets to the point where there's a resistor in parallel with a wire, well, the current's going to want to go the easiest way. So it's going to just go through the wire. So that resistor is essentially not going to be there. So it's going to be like you have 3 resistors. Okay. So now, so that's going to be the last measurement. You're going to have to predict what it's going to have to be and understand what's going on. Let me talk to you a little bit about how an ohm meter works. Okay. So now an ohm meter has to inject some energy into the circuit to make its measurement, and it uses Ohm's law. So V is equal to IR. That's Ohm's law. Okay. So now let's say we had a multimeter, an ohm meter. So let's say this is our ohm meter, right? Ohm meter. Okay. So now one way that we can make an ohm meter is to use a constant current source of a known value, okay? And that could go out to the terminals, okay? And let's say that is, well, I've actually measured this in a ohm meter, and let's say it is 1 milliamp, okay? So it tries to push 1 milliamp. And then let's say we had a voltmeter inside that ohm meter. So this is a voltmeter, okay? And if we were to measure the voltage across here, and then if we were to put a resistor on the outside, so let's see, this is going to be a resistor. So this is my resistor. And then we have the leads coming out of the voltmeter. So let's just say I have the red lead coming out here, touching the resistor, and I have the black lead coming out here and touching the resistor on the other end. Then we're going to have some current flowing, okay? So what's the current going to do? Let's say we use green. So the current is going to flow like this, down through here, and back in again, okay? And we're going to have some resistance. Let's say this is 1 kilo ohm, okay? Okay, so how much current is flowing through that? So we have 1 milliamp, right? Okay, so let's just say that current is 1 milliamp because that's coming from the current source. So then we could use Ohm's law to find the resistance. So R is equal to V divided by I, right? So now we know that I is always going to be 1 milliamp, let's say, right? And then we just have to measure V, okay? And we can predict what V is going to be, right? It's going to be, well, it's V is equal to IR, okay? And we know it's 1 milliamp times 1 kilo ohm, which is going to be 1 volt. Okay, so we know we're going to be measuring 1 volt here, right? And then, so that's the measured value, okay, the 1 volt. And then the ohm meter is going to do the calculation and say that it's measured a 1 kilo ohm resistor, okay? The reason why I'm giving you this explanation is so that you understand that when you make a resistance measurement with an ohm meter, the ohm meter puts energy into the circuit like a current source, and that will go everywhere in the circuit that it can. So that's why you have to isolate the resistance that you want to measure, so that you just measure the resistance of that component, okay? Otherwise you measure the resistance of the entire circuit that the ohm meter is connected to. Now there could be another, a different construction of the ohm meter, and instead of a constant current source it can have a constant voltage and then measure the current, okay? So it uses Ohm's law both ways, and both would work, okay? So that is the ohm meter. And then the next piece is using the ammeter and making current measurements. Okay. So now this is now this can be tricky. So what it's saying, first, of course, remove the power, and we get rid of the short circuit between the nodes, Y and Z. So let's just go back up there. Let's erase this. So it's saying get rid of this short circuit, so get rid of the one across here, okay? And then let's put these back in, okay? So that's going to be the circuit we're working with, and it wants us to get rid of that short circuit and then reconnect this bottom one, okay? But we leave this top one open, okay? So this one has to stay open because this is where we're going to put the ohm meter. I mean the ammeter, which is the current meter. Okay, so then we put the ammeter in here. So let's say I use blue. So let's say I'm using AM for the ammeter. Okay, so that's this device, and then it wants me to put the red lead connected to this point and the black lead connected to this point. Okay. And now with your knowledge of how ammeters work and with your knowledge of Ohm's law, you can actually calculate what that current is going to be and whether it's positive or negative. Okay? So that's what that measurement is going to be. And then it asks you, let's see, it asks you to connect the voltage source, okay, yeah, to Y and Z. Okay. Okay, so then it asks you to put the circuit back the way it was supposed to be, like so, okay? Restore the circuit, and then put the ammeter in like so. Ammeter. And then you connect it like so at point Y, and then like so at point Z, okay? And then make the measurement. And then you have to interpret the results that you get when you measure the current. And I'll tell you right now, this is a way of using the ammeter that's incorrect, okay? It's safe the way that it's drawn and connected, okay? So it's okay, but you're going to get a garbage measurement, and that's got to do with the properties of the ammeter. So that's the question that you're asked in part 3 there, so that you have to figure that out and have an explanation for that. So then later in the lab, talks about making measurements with the oscilloscope and using the waveform generator, and there are a lot of detailed instructions. And so I'll have you follow those instructions when you do the lab. So I'm not really going to talk about it, and but recall what you observed in the video explaining the oscilloscope, and now you're going to punch in everything and get your hands-on knowledge about using it. And I really encourage you to do some experimentation and play around and look at all the features and functions of the oscilloscope and the waveform generator, so that you are comfortable with it and can use it more fluently, so that you can use it in the later labs. Okay, so I think that's it for what I'm going to say about the Lab 1. Enjoy it, okay, and watch those instrument videos. Take care.